Last episode, why Edge AI became real. Today, zooming back in, Gemma 4 is not one model, it's a family. Let's start there. Gemma 4 comes in three sizes, 4 billion, 12 billion, and 27 billion parameters. They share core design choices. Each size is tuned for different deployment hardware. One family, three options. The 4B fits on mobile-class hardware and small embedded systems. The 12B runs on consumer GPUs like an RTX 4060. The 27B needs workstation or server-class compute. Match the model to the hardware. What makes them a family is shared design. Same training approach, same core architecture, same output behavior patterns. Move from 4B to 12B to 27B, and you trade size for capability, not behavior. Why does this family structure matter? You can prototype on the small model. Deploy at the size your hardware supports. Easier than choosing between completely unrelated models. Three sizes, one family. The question now, what's actually inside them? Next, the technology underneath. Last segment, the family. Today, what's actually inside Gemma 4? Three core ideas you should know. High level, just the intuition. Foundation 1, the transformer. A stack of neural network layers, each refining the input further. The same architecture family powering GPT, Claude, Llama, and Gemma. Different details, same blueprint. Core idea 2, attention. When the model processes a word, it looks at other words to understand context. Each word attends to others. The model figures out which ones matter most. Before transformers, models process sequences one step at a time. Attention let them look at the whole sequence in parallel. That breakthrough unlocked the entire large language model era. Third concept, mixture of experts, MoE. Instead of using the entire model for every input, the model has specialized subnetworks. A router picks which experts to activate. Only the relevant experts run. Three ideas, transformer foundation, attention for context, mixture of experts for efficiency. Next, how Gemma 4 uses these to fit on edge hardware. Last segment, the technology underneath. Today, what specific design choices let Gemma 4 fit on edge hardware? Three real engineering decisions. Choice 1, a compact token vocabulary, smaller than GPT-class models. This shrinks the embedding tables, the largest memory consumers in transformer models. Less RAM to load, faster to swap between models. Choice 2, efficient attention. Gemma 4 uses grouped attention heads with shared key value caches. Standard attention scales quadratically with context length. Grouped attention keeps the cache linear-ish. Long contexts become affordable. Choice 3, right-sized layer counts. The 4B has fewer layers than the 27B, but they share the design blueprint. Each size is tuned for a hardware tier. Pick the size that fits your VRAM. The practical result. The 4B fits in 3 to 4 gigabytes of VRAM, the 12B in 8 to 10 gigabytes. Consumer hardware like an RTX 4060 handles them. Three architectural choices, all connected to real edge deployment outcomes. Next segment, what got traded away to make these choices? Last segment, the choices that make Gemma 4 edge-friendly. Today, what those choices cost. Every architectural decision has a price. Trade-off 1, reasoning depth. Compact models, even well-tuned ones, reason less deeply than frontier-scale cloud models. For heavy logic chains, the larger models still win. Edge handles simple, cloud handles complex. Trade-off 2, general knowledge breadth. Smaller models literally hold less information. Trivia, obscure facts, niche domain knowledge, all weaker. The good news, retrieval augmented generation, RAG, fills this gap. Trade-off 3, peak quality. On any single hard prompt, frontier cloud LLMs usually produce better answers. But Gemma 4 delivers consistent quality across many prompts. Good enough every time, often beats sometimes great. The trade in summary, Gemma 4 gave up some peak capability. It gained ownership, privacy, and cost predictability. For many real use cases, that's the right trade. Gemma 4 is engineered for edge, architecture, choices, trade-offs. That ends episode 3. Subscribe to follow the series. Episode 4 next, a deep dive on dense versus mixture of experts.